Okay, this is an example where you basically can expand a fraction by treating it as two separate binomial expansions. So the first thing to do is think about rewriting this. 1 plus x squared all over 1 minus 2x is the same thing as having 1 plus x squared times by 1 minus 2x to the power of minus 1, because that gives you 1 over 1 minus 2x. That should be relatively obvious. And then you can expand both of these separately. 1 plus x squared, I don't think we really need a binomial expansion for, but I might just show you what's happening with it. I've popped the formula up here. That's the first three terms. That's all we're after. So in this case, n is 2 and x is just x. So you get 1 plus 2x plus 2 times 1 over 2 factorial lots of x squared. I'm sure you know already it's 1 plus 2x plus x squared. You will get ascending powers of x for these, which is the way round you want it. If you tried to find the next term of this one, just out of interest's sake, you would do n minus 1, n minus 2 over 3 factorial x cubed, and you'll introduce this 0. So when you've got positive powers of n, this expansion here still works, but it will terminate because you'll end up timesing by 0. So I thought you might like to see that. 1 minus 2x to the power minus 1. So now my n is 1 and my x is minus 2x. So n minus 1 x minus 2x. And that gives me 1 plus 2x plus, they were going to cancel off, 4x squared. Validity on x, this one's valid for modulus of x less than 1 or minus 1 less than x less than 1. The second of these is valid for modulus of 2x less than 1. So minus a half less than x less than 1 when you divide 3 by 2. Oops, sorry, less than a half when you divide 3 by 2. Right, so I have this expansion here, first three terms. So the fraction 1 plus x squared over 1 minus 2x is approximately equal to, so I'm finding a few terms of it, these two multiplied together. Remember the terms, as you move along, the powers of x get bigger and bigger. So we have ascending powers of x in these binomial expansions. So the first three terms of this, I'm only interested in the number, the x, and the x squared terms. Anything beyond that is going to be pretty meaningless because it'll be part of the next term along. So I'm expanding, but I'm going to ignore anything beyond x squared. So I'm going to start by timesing through all of this by 1. 1 plus 2x plus 4x squared. Then I'm going to times through by 2x, so I get 2x plus 4x squared. But I've ignored the 8x cubed, that's part of the next term along. And then from here, so times 3 by 2x, and I'm times it by x squared, so I get x squared but I don't want the x cubed and the x to the 4 terms. So plus x squared, and then it's just, okay, so tidying that up. So I've got 1 plus 2x plus 2x is 4x plus 9x squared. And then the validity on x, you need to take the tighter restriction out of these two. So this one is valid between -1 and 1. This one is valid between -1/2 and 1/2. So the whole thing is valid for x between -1/2 and 1/2. If x was something like 3/4, it would be okay for this one, but not that one. So we need the values of x which are okay for both of those expansions, which is your tighter restriction on x.